Hello guys, this is Dave. Today we are going to solve some more questions, okay? Alright, so this is the first question. You have to read the question very carefully. It's written that two particles of mass m each are tied to the ends of light string of length 2a. So this is the initial length of the string. The whole system is kept on a frictionless, just encircle this, frictionless horizontal surface with the string held tight so that each mass is at a distance a from the center P. So here is the center and each mass is at an equal distance a from the center. Now the midpoint of string is pulled vertically upwards with a small but constant force F. You see it is written force is constant. You see the word constant over here. Alright. As a result, the particles move towards each other on the surface. The magnitude of acceleration when the separation between them becomes 2x. Alright, so from 2a it has reduced to 2x. Alright. So this is the original diagram, okay. These are the two masses. This is the point P and each mass is at an equal distance from the point P, which is A. So how will you solve this question? We have to find out the acceleration when the distance is 2x between the mass. So at any point of time, you see this force will pull the thread upwards, and at any other point of time the figure will be like this. Okay, so masses will come closer and this will be the force. Alright. Now, the whole distance is 2x over here. This was the point P. Let us say this is A, B and this is O. Now you see this will remain A because F was applied at P, which was equal, okay, from both the ends. This is also A. Alright. This is 90, this is 90, okay, and this is a common line. You see PO is common, okay, and angle POA equals angle POB and PA equal to PB. So these three conditions tell us that triangle APO is similar to triangle BPO. Alright. So since these triangles are similar, the common side is this. Hence, due to their similarity, these angles will be similar. This is theta, then this is also theta. This angle will be same. Hence, the two sides from the O, which is AO, would be equal to BO. Alright. So if this was 2x, then this will be x and this will be x due to their similarity. Alright. The first thing you need to know is this. Okay. Now, I am redrawing the figure over here. This is x and this is x. Okay. So now we have to calculate the acceleration. This is A, this is A. First, we take this point P and draw the free body diagram. Okay. Since there is no mass at the point P, because the string is obviously assumed massless, as I told you in my earlier previous videos. So the free body diagram at P is somewhat like this. This is F, right? These are the two tensions, okay? Since this string is 1, okay? This string APB is one string, okay? APB is one string. So the ends, the tension at the ends will be the same, alright? At point P. Since this is an external force, okay? So you see, as the force is constant and it is moving slowly, alright, and since this is massless, so acceleration is of no use over here. So A would be, even if A is not 0, you see mass is 0, alright. So the net force here would be equal to, since this was angle theta and this is theta, right, because this is theta, this would be 90 minus theta, this would be 90 minus theta. So F minus 2t sine theta would be equal to mass into acceleration. Since string is massless, hence this would be 0. So F would be equal to 2t sine theta. Alright. This is the first equation. Okay. So now we take another free body diagram of this. You see this mass M at A. This would be pulled by the string in this direction, and this is T, right? because here we had assumed t, so here will be t. Alright, this is t and this is the angle theta. So what would be here? T cos theta would be equal to mass into acceleration. Since this is pulling this mass in the horizontal direction, this component will be t cos theta and this component will be t sin theta, right? And the vertical equation would be t sin theta plus n would be equal to mg. Alright, since this is the normal of the surface and this is the weight of the mass, this will balance out and hence we have t cos theta equal to ma. So we substitute the value of t from this equation. T will be equal to f by 2 sin theta and this would be cos theta above, this would be equal to ma, right? So f cos theta by 2 sin theta equal to ma, and this is the figure. This is x, this is x, this is theta, and this is theta, and this is a. Alright, so this is f by 2 cot theta equals ma. This would be, a would be equal to f by 2m times cot theta. Now what is cot theta? You see, tan theta would be equal to PO divided by AO, because this perpendicular, tan theta is perpendicular by base. So what is PO over here? Using Pythagoras theorem, we can say PA square would be equal to PO square plus AO square. So PO would be equal to root under A square minus X square. You must know this, okay? If you don't know this, then it is very difficult. And AO is X, right? So what is cot theta? Cot theta is reverse of tan theta. So we have f by 2m times x divided by a root under a square minus x square. This is the answer, okay? This is the answer of the acceleration. So you see, this is the exact expression which I have calculated, f x divided by 2m times root under a square minus x square, and this is the answer B. Alright, so B over here is the acceleration. So I am giving you another condition. What would have been the acceleration had there been friction over here? You see, here it is written it is frictionless. What would have been the acceleration if it was not frictionless, and if I had given you the friction coefficient as mu? Okay, so this was the original figure. Only point that I am adding is here, now the friction, now there is friction, okay, and coefficient of friction is mu. So now I want to find out the acceleration. Now how will I find out the acceleration? So at any point of time t, the figure will remain same, the masses will come close, alright, and this is a, this is a, this is perpendicular, this is common, this would be x, this would be x. Now the only difference is in the free body diagram. You see, at the point P there is no mass, okay, so there, since the string is same, tension will be same, so F equal to 2t sin theta will remain, okay, if I consider this angle as theta. This equation remains as the string is massless. Now only change occurs over here. You see, at this point A, this is the mass and this is the tension T pulling here. The component of T, one will be like this horizontally, this would be T cos theta, other would be the vertical component T sin theta. But in addition to this, there would be a frictional force which would resist the motion. This would be F, alright. Okay, so this friction force will resist the motion, and so the FBD is over here, and another force which is the normal will be applied by the surface, and this will be the weight of the particle. Alright, since acceleration is taking place, the horizontal components will not be balanced, so the equation is T cos theta minus F. This would result in m into a, alright, and the vertical components will be balanced because acceleration is only horizontal. This is acceleration AC, this AC will differentiate from this A, okay. So the vertical equation will be n plus t sin theta, this would be equal to mg. Now this is the equation, okay. Alright, so we can calculate n here. N would be equal to mg minus t sin theta. Alright, and friction was the coefficient of friction times the normal, right? So we have t cos theta minus mu times n was mg minus t sin theta. This would be equal to mac. Alright, now I'm writing it here. T into cos theta plus mu sin theta minus mu mg is equal to ma. Okay, so t into cos theta plus mu sin theta minus mu mg is equal to ma, and f equal to 2t sin theta. We can substitute the value of f, we get f by 2, and this is cot theta plus mu minus mu mg, this will be equal to ma. So a here is f by 2m mu plus cot theta minus mu g. Alright, this is the answer. And from the previous expression we had calculated cot theta. Cot theta came out to be x divided by a square minus x square the root. So we can put this here, and this is the answer. Alright, so you see how acceleration changes, and if we put mu equal to 0, we get f by 2m cot theta, and we can put cot theta here. This is the original answer we got. So in case of a friction and a coefficient of friction, this will be the answer. Alright, so let's take up another question. Here we see that it is given a block of mass m starts moving on a rough horizontal surface with a velocity v. Alright, so this is a surface and this is the block, and this is moving with a velocity v. It stops due to friction between the block and the surface after moving through a certain distance. Okay, the surface is now tilted at an angle 30 degree with the horizontal, and the same block is made to go up on the surface with the same initial velocity. The decrease in the mechanical energy in the second situation is much smaller than the first, and this is because before looking at the statements we have to find out what is the decrease in mechanical energy. Alright, so you see this is the first situation where the block of mass m is moving with a velocity v and it stops. So you see final velocity is 0, vi, initial velocity is v. One thing you see, since it is a horizontal surface, the only energy the block has is the kinetic energy. So potential energy is 0. So since we assume the surface to have 0 potential energy, okay, as surface is the reference point, so the total mechanical energy would be equal to the kinetic energy of the block, right? So what would be the change in mechanical energy would be the same as if the kinetic energy would change. Alright, so the change in mechanical energy would be equal to the change in kinetic energy. So what will be the change in kinetic energy? This would be equal to minus half mv square, right? Because this was 0 and this is half mv square. So ke final is 0 and ke initial is half mv square, right? So subtracting final from initial we get this. But what what has made the block to come to rest? It is friction. So the change in kinetic energy actually is the work done by friction. Work done by friction force, because the block has essentially come to rest due to friction. So work done by friction was minus F times S. Alright, this S is the distance, whatever it may be. Alright, so minus F times S is the work done by friction, which is equal to this. So change in mechanical energy over here is minus half of mv square. Alright, or we can say minus F times S, and S can be calculated. I don't have the friction coefficient right now, it's not given the question, so I assume minus half mv square for the time being. Alright, so let us now consider the next situation where the block is moving at an angle 30 degrees. The surface has been tilted. Here the friction we have, and the velocity here is v initial and the final velocity is 0. What if friction was not there? Suppose friction is 0, alright. Then that means at this point A and this point B, there are two different mechanical energies. Here at point A, potential energy is 0. And suppose if this is the height h, here point B, the potential energy would be equal to mgh, right? Here the kinetic energy would be equal to half mv square. Here kinetic energy would be equal to 0. So what will be the change in mechanical energy? This would be mgh plus 0, which is the mechanical energy at final point B, minus 0 plus half mv square, right? Delta me would be equal to mgh minus half mv square. But this would be 0. So delta me would be 0 if friction was not there. Right? If friction was not there, the delta me, which means the change in mechanical energy, would have been 0, because all of the kinetic energy would have been converted into potential energy. Alright. So that is why, because the conservative forces was acting, so this means only gravity was acting over here. If friction was not there, that means the whole of the kinetic energy has been converted to potential energy. But if friction is there, friction is not 0, then that means the change in mechanical energy would be mgh minus half mv square, and this will not be 0. Alright. So why this will not be 0? This is because only there has been a partial conversion. This is partial conversion, alright, and this is full conversion. So there is a difference between the two. So since this is a partial conversion, the subtraction of this will result to something which will be the work done by friction, and the rest of the kinetic energy has been converted to friction. So here the change in mechanical energy is, since friction is given, this is mgh minus half mv square, alright. So it is written the decrease in mechanical energy in the second situation. So we have, this is the second situation, and what was first? First was minus half mv square, right? So this is the change. Now we have to calculate the decrease. Decrease means we have to take the negative sign of this. So this means minus delta me1 equal to half mv square, and minus delta me2 would be equal to half mv square minus mgh. So the decrease in the second situation is less than the first. Obviously, if this quantity is assumed x, half mv square we assume x, and mgh we assume a. This means x minus a is obviously less than x, right? So I have proved here the decrease in mechanical energy in the second situation is less than the decrease in mechanical energy in the first situation. Alright. So you see, the statement 1 is correct, because it is written the decrease in mechanical energy in the second situation is smaller than the first. This is correct. But this is not correct, the second statement, because here it is written the coefficient of friction between block and the surface decreases with the increase in the angle of inclination. This is wrong, because coefficient of friction can be the same as in the first situation. I have proved this without using coefficient of friction. Alright, the first statement has been proved using coefficient of friction. Hence statement 1 is correct, statement 2 is wrong. Alright, so I think C here is the appropriate answer. Alright, so let's take up another question. In this question, it is written in the first statement, in an elastic collision between two bodies, the relative speed of the bodies after collision is equal to the relative speed before collision. And in the second statement, in an elastic collision, linear momentum is conserved. Obviously, second statement is correct. Everyone knows in an elastic collision linear momentum is conserved. Only difference is that in inelastic collision, kinetic energy is not conserved. In elastic collision, kinetic energy will be conserved. Alright, so we have to see the first statement, whether it's correct or not. Alright. Okay. Alright, so let us take a very simple problem. In this problem, mass m1 is coming towards m2. m2 is at rest, and m1 is coming towards m2 with a velocity v. You see, so first we calculate the initial relative velocity before collision. So you see, before collision, the initial relative velocity will be v. If I calculate v of m1 minus v of m2, okay. v, and speed would be modulus of this. So even if we different, we take out the difference of the velocity of m2 minus velocity of m1, this would be minus v. But if we are calculating relative speed, so we take the modulus of this, so this is v. All right, in any case the relative speed would be v. All right, so let us consider the case of collision now. When they collide, this is the figure after collision. Let us say m1 acquires velocity v1 and m2 acquires velocity v2. This is after collision. Okay, so we all know momentum is obviously conserved over here, so we see m1v, this would be equal to m1 v1 plus m2 v2. This is the first equation, and since this is elastic, kinetic energy would be conserved, so half m1 v square, this has zero kinetic energy, and in the figure after collision, this is half m1 v1 square plus half m2 v2 square. Okay, half gets cancelled here. We square the first equation. Okay, so squaring the first equation, we get m1 square v square would be equal to m1 square v1 square plus m2 square v2 square plus 2 m1 m2 v2 and v1. Now we multiply the second equation with m1 over here. So we have m1 square v square. This would be equal to m1 square v1 square plus m2 m1 v2 square. That's it. Okay. So now we subtract both the equations. So this gets cancelled. This gets cancelled. All right. So we have final equation would be m2 square v2 square minus m2 m1 v2 square plus 2 m1 m2 v1 v2. This would be equal to 0. All right. So now just I'm solving over here. We take m2 common over here, so we have m2 times m2 and v2 square would be common also, m2 minus m1 plus 2 m1 m2 v1 v2 is equal to 0. v2 will get cancelled, will be common, m1 will not be cancelled, sorry, m2 will be cancelled, so m1 is here. So we have v1 would be equal to v2 times m2 minus m1 by 2 m1. Alright, so this is the expression for v1, and from here v2 would be equal to 2 m1 v1 upon, sorry, this would be minus because this would go over here, so this would be minus, so minus and this would be plus. Yeah, so we have 2m1 v1 upon m1 minus m2. Alright, this is the second v2 in terms of v1. Alright, so we have v2 would be equal to 2m1 v1 upon m1 minus m2, and the first equation it was m1 v equal to m1 v1 plus m2 v2. So just we substitute the value of v2 over here, so we have m1 v equal to m1 v1 plus m2 times 2 m1 v1 divided by m1 minus m2, and taking this expression over here, we have m1 square minus m1 m2 plus 2 m1 m2 times v1 would be divided by m1 minus m2 equal to m1v. So this will be subtracted, and we have over here m1v equal to v1 m1 times m1 plus m2 divided by m1 minus m2. m1 gets cancelled, so v1 is m1 minus m2 upon m1 plus m2 into v. Alright, so what is v2? Just substituting the value of v1 over here, we have 2m1 2 m1 upon m1 plus m2 times v. Alright. Yeah. We substitute the value of v1, the numerator gets cancelled with the denominator, and we have this value. Okay. So now we calculate v1 minus v2 or whatever. You know, v2 minus v1 or v1 minus v2, because we are calculating the relative speed, so it doesn't matter. So v1 minus v2 would give us this would give us minus of modulus, this is m1 plus m2 by m1 plus m2 times v. Minus gets cancelled due to modulus, this gets cancelled, this is v. Alright, this is v. So v relative initial would be equal to v relative final, and this was v. So the first statement here is correct. Okay, first statement here is correct. So first statement here is correct, second is also correct. Okay, and second is the correct explanation of first statement, and in my analysis A is the correct answer. Okay, alright, so let's move on to the next question. This is a very interesting one. It is written, a block of mass 2 kg is free to move along the x-axis. It is at rest, and from time t equal to 0 onwards, it is subjected to a time dependent force. This is the graph of the time dependent force given. Alright, the force f of t varies with t as shown in the figure. We want to find out the kinetic energy of the block after 4.5 seconds. This means the velocity of block at 4.5 seconds, and the square of it will give the kinetic energy, because the velocity at point O is 0. This is a graph, and from here we have to calculate the kinetic energy. And you know, you should read very carefully. This is the force versus time graph. This is not the force versus distance. Okay. Alright, so this is the original problem. This is the graph given. So I have to find out the velocity at 4.5, and squaring it, and mass is given 2 kg, so I can find out the kinetic energy. So how do we do that? First of all, I want to know the relation of force with respect to time. So force is a function of time here. Okay, because force is depending on time and a graph is drawn. Alright, so how do I do that? Because you know, this point, let us say this is B, this is A. Point B is not given. If we extend the graph downwards, the value of point B is not given. Still, I can find out the equation of graph by using these 2 points. You see, when time is 0, then I know that force is 4 newtons. And when time is 3, then I know force is 0. So I want to find out the equation if when I put these 2 variables of time, I get these 2 values of force. So as you all know, y is equal to mx plus c. This is the original equation of a graph of a line having slope m. What is the slope of this line? You see, first of all, this line is falling down. This line is not up. For example, if had this line been like this has a positive slope. Okay, positive slope. So m here is positive, but here m is negative, because this has a negative slope. It is falling down. So I for sure know that m is negative. Alright, so we have to find out the equation like this: f of t equal to m times t plus c. And I know when I put t 0, I will have to get the value of f equal to 4. This means when t equal to 0, f of 0 should be equal to 4. So this means this is c. So I now have the value of c. And what is the value of m? Obviously this is the slope, so tan theta, this is theta, right? And this would be negative, so I have the equation as like this: tan theta is 4 by 3, perpendicular by base. This means minus 4 over 3 times t plus 4. I now have the equation of force with time. Okay, this is the equation. You can see when you put t equal to 0, you have f equal to 4. When you put t equal to 3, 3 gets cancelled, and minus 4 plus 4 is 0. So this is the equation. Okay, so I now have f of t would be equal to minus 4 over 3 times t plus 4. Okay, So I want to find out the value of velocity at t equal to 4.5 seconds. So what is force? Force is m dv by dt. Change velocity, rate of change of velocity times mass, okay? Or we can say rate of change of momentum. And this is minus 4 by 3 times t plus 4. Dt can go over here, m is 2, so we have dv equal to 1 by 2. And I can take 4 common over here, minus t by 3 plus 1 dt. Now I'm going to integrate this from 0 to 4.5, okay? I'm going to integrate from 0 to v, because we started from 0 velocity as given in the question. You see, I can take time here from 0 to 4.5, because this equation will encompass all of the nitty-gritties of the velocities. So you don't need to worry, you just need to take the uniform time. This is we have, this gets cancelled, and this is t dt would be minus t dt would be t square by 2. So this would be minus t square by 6 plus t 0 to 4.5. So we have v equal to twice of minus of 4.5 whole square by 6 plus 4.5. This would be equal to 4.5 whole square is 20.25 minus by 6 plus 4.5, and this gets multiplied. I am solving over here. Twice of minus 20.25 plus 27 by 6. V is twice of, this would be 6.75. 27 minus 20.25 would be 6.75 by 6. This gets cancelled, so v equal to 6.75 by 3. So half mv square I have to calculate. Since m is 2, half and 2 gets cancelled, so I only have to calculate v square over here, okay? So 6.75 by 3 is actually 2.25, okay? So v square would be equal to 2.25 whole square, and this would give the value of 5.06 joule. This is the answer, okay? This is the final answer. According to me, this is the answer, okay? Let's see. C is the answer over here. Alright, so we got the C as answer. So guys, this was my analysis. I will cover more questions from previous years as I move forward with my concepts. Do rate, review, like and recommend, okay? Thank you.